today's class we'll be discussing on motion in a plane. Okay, in this chapter actually there are two topics. One is projectile motion, one is circular motion. In today's class we will focus more on projectile motion concepts and formulae. Okay, circular motion, let it be aside, we will be focusing on the upcoming classes. Okay, so let us start with the class. Okay, and regarding non-text section, we will start soon when we reach midway of text section. Since the classes are free, please give us time for the admins to figure it out. Okay, and for English we have a special plan. For English we will be starting uploading YouTube shorts in which daily vocabulary will be discussed. Along with synonyms and antonyms, because as far as we can tell by the question paper analysis, we can see that around 5 questions from English are from synonyms and antonyms. So before exam, if you have gone through at least 1000 words of synonyms and antonyms, this 5 marks is guaranteed. Okay, so let us start with today's class. So today's class we are starting firstly with motion in a plane. I have wrote that before. Motion in a plane. Pardon me for the handwriting because it's been a while since we have gone through the class. Motion in plane is also called as motion in 2 dimensions. That is also called 2D. 2 dimensions. Example: projectile motion, circular motion, etc. For the analysis of such motion, our reference will be made of an origin and 2 coordinate axes x and y. That is, we will be having origin and 2 coordinate axes x and y like this. This is x axis and this is y axis. Okay, now let us learn a few terms related to motion in plane. The first one we are going to learn is position vector. It is a vector that extends from a reference point to the point at which a particle is located. A position vector is given by r equal to xi cap plus yj cap. Okay, the direction of the position vector r is given by the angle theta with the x-axis, where direction tan theta equal to y by x, where theta points to the direction. In 3 dimensions, we can represent the position vector as like this. R is equal to xi cap plus yj cap plus zk cap. Okay. Now let us move on to the next one. The next one we are going to learn is displacement vector. Second one. Displacement vector. I'm just revising all the formula and concepts, not going in deep. So you guys must know all these things. Okay. The displacement vector is a vector which gives the position of a point with reference to a point other than the origin of the coordinate system. The magnitude of displacement vector, it is denoted as mod delta r equal to root of delta x square plus delta y square, which is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, note down this formula. The direction of the displacement vector delta r is given by delta r, direction of delta r is given by tan theta, which is equal to symbol, instead of y by x it will be delta y by delta x for displacement vector. In 3 dimensions, in 3D, the displacement vector can be represented as, implies delta r equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Okay. Now let us move on to the next one. Next one is third one. Velocity vector. Okay. Velocity of an object in motion is defined as the ratio of displacement and corresponding time interval taken by the object. In velocity vector, the first sub vector we need to learn is average velocity. It is defined as the ratio of displacement and the corresponding time interval. That is, average velocity is given by v, a, v. A, v is the suffix, equal to, it's the ratio of the displacement. Displacement, what is it? Delta r. And the corresponding time interval, it will be delta t. It is equal to what? Delta r is r2 minus r1. Delta t is t2 minus t1. See, simple. Average velocity can be expressed in the component forms as like this. In component form, we can write like this: VAV equal to delta x plus delta t I cap plus delta y by delta t j cap. This again equal to delta Vx I cap plus delta Vy j cap. Just know how the component form is written. Won't be asked in problems. Sometimes they will ask what is which one of the following represents the velocity vector in component form. What you're seeing in the RHS, either this or this can be the options. That's why. Okay. The direction of the average velocity, VAV, direction of VAV can be written as like this: tan theta equal to, what is it? Delta Vy by delta Vx. Okay. The next one is instantaneous velocity. Fourth one, instantaneous velocity. The velocity at any instant of time t is known as instantaneous velocity. It is given as v equal to limit delta t tends to 0 delta r by delta t, which is equal to dr by dt. Okay, we can again represent it as like this: v equal to dx by dt I cap plus dy by dt j cap. Again we can write like this: v is equal to vx I cap plus vy j cap. Okay, the magnitude of instantaneous velocity, magnitude of instantaneous velocity, magnitude of v, is given as, denoted as mod v, which is equal to root of vx square plus vy square. Okay, the direction of v is given by tan theta is equal to same vy by vx. Please note it down, guys. Okay, so we have noticed that some of you were asking for the PDF of the lecture. Unfortunately, we are not providing the PDF because the data is being cleared. Okay, so if you want to go through the whole concepts and all, please go through the video. That is fine. Okay, the next one is acceleration vector. Fifth one, acceleration vector. Okay, it is defined as the rate of change of velocity. The first one we need to know is average acceleration. Average acceleration. Okay. Average acceleration. It is defined as the change in velocity delta v divided by the corresponding time interval delta t. That is average acceleration. We are denoting it as like this: av as suffix equal to delta v by delta t. It is equal to delta vx by delta t I cap plus delta vy by delta t j cap. Okay, or you can write like this, that is average acceleration, which is equal to a average acceleration of its component of x I cap plus a average acceleration of y component j cap. Okay, the magnitude of average acceleration is given by mod AAV, is given as root of like this AAV x the whole square plus AAV y the whole square. Okay, the angle theta made by average acceleration, that is the direction of average acceleration, is given by like this: tan theta is equal to ay by ax. Okay, I'll just clear this. The next one we need to learn is instantaneous acceleration. Is it instantaneous acceleration? Okay, it is defined as the limiting value of the average acceleration as the time interval approaches to zero. That is, instantaneous acceleration is given by a is equal to limit delta t tends to zero delta v by delta t, which is equal to dv by dt. Okay, that is the instantaneous acceleration. We can write as a is equal to ax I cap plus ay j cap. If the acceleration a makes an angle theta with x-axis, then tan theta equal to ay by ax. Okay, let us go to study the next concept. Next concept, write the heading: motion in plane with uniform acceleration. Okay, a body is said to be moving with uniform acceleration if its velocity vector suffers the same change in the same interval of time, however small. According to the definition of average acceleration, we have a is equal to v minus v0 divided by t minus 0, where v0 is v0 is same as u, equal to u. Okay, it is again given by v minus v0 by t. Okay, also we have v is equal to v0 plus 80, that is v is equal to u plus 80, right? In terms of rectangular component, we can represent vx is equal to ux plus ax into t, vy is equal to uy plus ay into t. Okay, okay, now let us move on to the main concept of today's class: projectile motion. Okay, projectile motion. Regarding projectile motion, in terms of theory and deep concept, there is a lot more to tell. But here I am only explaining just the main concept, the formulas associated with it, and few figures if necessary. Okay, so everyone listen carefully what I'm about to say. When any object is thrown from horizontal. Okay, let's assume that this is the horizontal. Okay, I'm throwing an object. Okay, this is the point. I'm throwing an object at an angle theta such that theta cannot be 90. That is, I'm not going to throw it vertically, but I'm throwing it from the horizontal at an angle theta except 90 degree, and it's going to move parabolic. That is, if it is moving parabolic, it will throw from here and reach here. Okay, so it's throwing at an angle theta. Okay, so if theta this is okay, I'm throwing at a velocity, let's say u. Okay, sorry for this, I'm just drawing a rough figure. Okay, at a velocity u, or I'll do one thing, 1 second guys, let me check whether I can make it meaningful. Everyone please go through the class up to date. Okay, because if you push on to the next day, every day we will feel like let's push on to the next day, and that next day will be your exam date. That's why. So maximum watch the classes daily. Okay, let's say we have a horizontal surface, let's say here. Okay, horizontal surface. Okay, so I'm going to throw a ball at an angle theta with an initial velocity u. This is the angle theta I'm going to throw. So this, it will be going like this and reaching here. Okay, that is initial velocity of u. So what will be the vertical component? So if I'm drawing the vertical component here, this is the vertical component, this will be u sine theta. And what will be the horizontal component? This will be the horizontal component, that is u cos theta, right? Acceleration, gravity, there will be gravity downwards. Okay, so let me just tell a definition for it. Okay, when any object is thrown from horizontal at an angle theta except 90 degree, then moves on a parabolic known as the trajectory. This parabolic thing, okay, this parabolic path is called trajectory. Okay, the object is called projectile and its motion is called projectile motion. If any object is thrown with a velocity u, here the object is thrown with a velocity u making an angle theta, it is making an angle theta with the horizontal, then the horizontal component of initial velocity is what? U cos theta. So this is the horizontal component. Okay, so this is the horizontal component, and what is this? This will be the vertical component of initial velocity. Vertical component. And what is u? U is the initial velocity. Everyone please note each and every point down. Okay, this is a very important topic for ATC exam. Okay, now let us learn some terms and important equations regarding this projectile motion. The first one we need to learn is time of flight. Okay, the first one we need to learn is time of flight. I'll just state a basic definition of time of flight. It is defined as the total time for which the projectile remains in air. The equation is given by, it is denoted as T. T is equal to 2u sine theta by g. Okay, this is time of flight. Maximum height. The next one is maximum height. It is defined as the maximum vertical height covered by the projectile. It is given by h is equal to u square sine square theta by 2g. Okay, maximum height. The next one is horizontal range. Horizontal range means it is defined as the maximum distance covered in horizontal distance. The equation is r equal to u square sine 2 theta by g. So everyone, these three equations are very important. It has been asked in various ATC exams, JEE mains, advanced, KEAM, NDA, railway exams, many exams. Okay, please note down these three equations. Okay. Okay, so regarding projectile motion, now we need to note down a few points. Okay, that is important formulas related to projectile motion. One by one we'll go through. Okay, important formulas. No need to know how the formulas came into being, but just study the formulas. Okay, first one. At highest point, the linear momentum is mu cos theta. Okay, linear momentum equal to mu cos theta. Okay, and the kinetic energy is equal to half into m is the mass, m to u cos theta the whole square. Instead of b square, it will be u cos theta whole square. Okay, second formula. I'm not explaining how this came into being, but just study the formula. Okay, the horizontal displacement of the projectile after t seconds. Horizontal displacement of projectile after t seconds. X is equal to u cos theta into t. Okay, similarly, third one, I'm not writing like this. The vertical displacement of the projectile after t seconds. Vertical displacement of projectile after t seconds. Y is equal to, here there's a small difference, u sine theta into t, but there's, I have told you, there's a gravity acting downwards, so it will be like this, u sine theta into t minus half gt square. That is, y is equal to ut minus ut plus half at square. So when there is gravity acting, we know that ut minus half gt square. Since u is replaced as u sine theta, the equation becomes like this. Okay. The next equation, fourth one, right? Fourth one, equation of the path of projectile. Equation of the path of projectile. It is given by, it's a pretty long equation, but everyone please study this equation, it's very important. Y equal to x tan theta minus g by 2 u square cos square theta into x square. That is y is equal to x tan theta minus g by 2 u square cos theta, cos square theta, cos theta cos square theta into x square. Okay. The next one is an entrance point. Path of a projectile is always parabolic. Path of a projectile is always parabolic. This is an entrance point. Okay. Sixth one. Velocity of the projectile at any instant t is given by mod v is equal to root of u square plus g square t square minus 2u gt sine theta. Okay, this is the velocity of the projectile at any instant t. Okay, seventh one is, alright, I'll write here, seventh one, kinetic energy at the lowest point. Kinetic energy at the lowest point is given by half mu square. Okay. Okay, eighth one, linear momentum at lowest point. Linear momentum lowest point equal to mu. Okay. Okay, now some extra points I just dictate. Acceleration of projectile is constant throughout the motion and it acts vertically downward being equal to g. I have explained in the figure before, I guess. Here I had told you the acceleration is always downwards because of gravity, that is g. Okay, next one is angular momentum of the projectile equal to angular momentum will be equal to mu cos theta into h. H, where h denotes the height. H is denoting the height. Okay. In case of angular projection, the angle between velocity and acceleration varies from 0 degree less than theta degree less than 180 degree. Okay, theta will be in degrees. Okay, I'll repeat. In case of angular projection, the angle between velocity and acceleration varies from 0 degree less than theta degree less than 180 degree. The projectile attains maximum height when it covers a horizontal distance to half of the horizontal range. Okay, so this is an important point. Note it down. When does the projectile attains maximum height? It attains maximum height when horizontal distance. I'll write as an extra point. I'll write here. Okay. When horizontal distance equal to half of the horizontal range. Horizontal range we are denoting it as r, right? So half of horizontal range means r by 2. That is when horizontal distance is equal to r by 2, that is half of the horizontal range, implies projectile attains maximum height. Projectile attains maximum height. Okay. Another point. Okay, right here. When the maximum range of projectile is r, it is when when r max, that is r max means maximum range of projectile equal to r, then its maximum height is r by 4. Okay, when r max is equal to r implies h max is equal to r by 4. That is, when the maximum range of the projectile is equal to r, then the maximum height is given as r by 4. This is also an entrance point. Very, very, very important. Okay. Next point. Horizontal range is maximum when it is thrown at an angle 45 degree from the horizontal. Okay. Horizontal range at r is maximum when theta is equal to 45 degree. Okay, that is, at that time what happens to r max? R max will be given by u square by g. That is okay. For next point, last point. Okay, for angle of projection theta and 90 minus theta, the horizontal range is same. Horizontal range same. Okay, so all these things are enough to study for projectile motion concepts. The next class we'll be discussing about circular motion. I hope all of you understood the class. Please note down each and every formulas as well as concept point, important entrance point as well, because these things can be asked directly for the exam. So there's no need to create another formula if you know this exact point. So many people have been asking about next AAI ATC vacancy, and many coaching centers have already started classes, I have heard. So our estimate guess for the latest vacancy in 2024 is on or before September. Okay, So I hope all of you start studying right now and also focus more on 11th topics as well, because in AITC 2023 90% of questions came from 11th topic. Okay, so we must accept that 11th topic can also be asked. Okay, in tomorrow's section we will either be going through circular motion concepts and formula, or we'll be going through projectile motion based questions, numerical workout questions along with their solutions. So I hope all of you understood the class. Thank you and have a nice day.